So, are you tired of debugging what feels like AI magic? That moment when you're a developer, you're trying to build these powerful AI agents, and you just hit a wall of black box frustration. Well, if that sounds familiar, you really need to know about a framework called Griptape. And in this explainer, we're going to dive deep into how this Python framework is designed to put you back in the driver's seat.
All right, here's the game plan. First, we'll tackle what I mean by the problem with magic. Then, we'll see how Griptape flips the script and gives you control. We'll break down exactly how it works under the hood and even see it in action with a slick Claude example. After that, we'll throw it in the ring with some of the other big names out there and finish up by asking, is this explicit approach the future?
Okay, let's kick things off with Section 1, the problem with magic. And we're talking about that feeling when an AI framework just hides way too much.
I mean, we've all been there, haven't we? Your AI agent is just humming along, everything's perfect, and then, suddenly, it's not. And when you pop the hood to figure out what's wrong, it's like it's been welded shut. You're just stuck staring at this black box, with absolutely no idea what's happening on the inside.
This quote from one of the articles we looked at just nails the feeling. Debugging why the agent called the wrong tool at Step 7 is a weekend project. A weekend project. Think about that. That's the real cost when there's too much abstraction, too much of that magic going on.
And that pain point is exactly where Griptape comes in. Their whole philosophy is no magic, all control. Let's take a look at how their approach to building AI apps is fundamentally different.
So, at its core, Griptape's philosophy is all about handing control back to you. It's really built on three big ideas. First, an explicit structure, so you always know what's happening. No surprises. Second, typed artifacts, which just means your code is way more robust. And third, and this is a big one, a driver system. The best way to think about this is like having a box of universal adapters. You can swap out your LLM provider, your vector store, whatever, and you never have to touch your core business logic. It's brilliant.
Okay, so what does that actually mean for you, the developer? It means you can build real production-grade AI agents and have total explicit control over the entire workflow. You can use any LLM you want. There's no sneaky prompt injection happening behind the scenes. And best of all, no vendor lock-in.
So how does Griptape actually pull this off? How do they deliver on that no magic promise? Well, let's get into the nitty-gritty and look at its three core layers.
Okay, at the highest level, you have what Griptape calls structures. This is basically the container for your whole operation. You can pick an agent if you need something conversational, like a chatbot. You can use a pipeline for tasks that need to happen one after the other. Or you can use a workflow to run a bunch of stuff at the same time, in parallel. It's all about choosing the right shape for the job you need to get done.
Now, inside those structures are the tasks. These are like your Lego bricks. They're the individual building blocks of your application. You've got things like a prompt task for chatting with an LLM, a toolkit task for using external tools, say a web search, and even a code execution task to, you guessed it, run some Python code. Each one is a clear, distinct, controllable step.
And this brings us to the third layer, the drivers, which is really where all that modularity magic, or, well, anti-magic, happens. Remember those universal adapters? This is them. Want to switch from Anthropic's Claude to a different model? Just swap out the prompt driver. Moving from a local database to one in the cloud? Swap the vector store driver. The whole time, your actual application code, your business logic, remains completely untouched. This is how you escape vendor lock-in.
Okay, now this is where things get really cool. Griptape's memory model is, and I don't say this lightly, a total game changer, especially if you're doing anything with RAG. So you've got your normal conversation memory and meta memory, but the star of the show is task memory. Picture this. Your RAG tool finds a massive 50-page document. In most frameworks, you try to cram that into the prompt and just blow up your context window. With task memory, that huge document is stored separately. The LLM just gets a simple reference to it. It is an incredibly elegant solution that keeps your prompts lean and efficient. This is a massive deal for building complex, real-world apps.
All right, enough theory. That all sounds great, but let's see what it actually looks like in practice. We're going to walk through a super simple, minimal code example using Griptape with Anthropic's Claude.
And getting started is, well, it's about as easy as it gets. It's literally just 2 pip installs. First, you grab the core Griptape library. Then, you install the specific driver for the service you want to use. In our case, that's the Anthropic driver to connect with Claude.
And here it is. This is the code to spin up a basic agent. Just look at how clean and readable that is. There's nothing hidden here. We're creating an agent. We're explicitly telling it to use the Anthropic prompt driver. We're specifying the exact model we want, Claude Sonnet 4-6. And we're even giving it a simple rule to follow, like always cite your sources. It's all right there. No magic, no guesswork. Just clear, explicit code.
Okay, so we see how Griptape works, but how does this explicit philosophy actually stack up against the big players in the space? It's time for the AI framework showdown, Griptape versus the alternatives.
This table breaks it down nicely. You can see right away how Griptape is carving out its own space. It's laser-focused on agents and workflows, whereas something like LangChain aims to be the kitchen sink for everything. Llama Index is, of course, the king of RAG. But look at these other rows. These strict type safety in Griptape, that's a huge win for catching bugs early. And again, that built-in task memory, it's just such a killer feature compared to having to roll your own solution in other frameworks.
But of course, we have to be real about where things stand in the ecosystem right now. And this chart of GitHub stars tells a pretty clear story. Griptape is the newer kid on the block. It just doesn't have the massive user base or the sheer volume of community contributions that giants like LangChain and Llama Index have built up over time.
And that smaller ecosystem naturally leads to some trade-offs you have to consider. It might mean you have to write your own integration for a specific service that would just be available out of the box in LangChain. Also, it's worth knowing that Griptape Cloud, which is their managed execution platform, is a paid service. And finally, while it handles parallel workflows well at a high level, more advanced async operations within tasks are still a work in progress.
All right, let's bring it all home. Section 6, the future is explicit. We'll recap the most important takeaways and look at what this all means moving forward.
So, after all that, why should Griptape be on your radar? I think it boils down to three huge things. Number one, explicit control. It leads to AI that's predictable and, most importantly, debuggable. Number two, modularity. That driver system is your escape hatch from vendor lock-in. It gives you freedom. And number three, that powerful memory. Seriously, the task memory feature alone is a reason to check it out, especially for complex RAG workflows. It's a genuine game changer. Look, if any of this sounds interesting and you want to learn more, the Griptape team has a ton of great resources out there for you. You can jump into the code on GitHub, go through the official docs. They even have free courses at something called the Griptape Trade School, which is cool. And of course, you can join the community on their Discord server.
So, I'll leave you with this one final thought to chew on. As the AI systems we build get more and more complex, is the path forward less about finding the right magic framework and more about embracing masterful, transparent, and explicit engineering? It's a big question, and the answer might just shape how you build your next big thing.